This time, let's look at graphing cosine functions. So the nice thing is with cosine functions, our equation is still the same. It's just using cosine. So y equals a cosine of k times the quantity x minus b, and then plus c. So a is still the amplitude that affects the vertical stretch. K is still related to the period. It's not the period, but related, and it changes the period, affects the period. B is our phase shift or our horizontal shift, and then C is the vertical shift. So to graph cosine functions, we'll do them exactly the way that we do sine until we get to the end, where we actually draw the curve in there. So I'm going to start by figuring out all my values. So my amplitude, so for this first example, we have y equals -5 times the cosine of pi over 4 times x. So my amplitude in this case is 5. It is negative, which means I want to remember that it is reflected. Okay. My k value is pi over 4. And so that means my period is going to change. My period is going to be 2 pi divided by k. So divided by pi over 4. And if we simplify that, we're going to have 2 pi times, do the reciprocal, so 4 over pi. 4 over pi. The pi's are going to cancel out. 2 times 4 is 8. So this period, instead of being having a length of 2 pi, it's actually going to have a length of 8. So it's how long my graph is going to be. It's how wide that box that we're going to draw is going to be. Then we look at our b value. There's nothing in here, so it's just a 0. And our c value, which there's nothing on the outside, so that's just a 0 as well. So the graph is not moved, it's not shifted left or right, it's not shifted up and down. So the midline is still the x-axis. So we'll kind of put that midline in there. The amplitude was 5, so from the midline we're going to go up 1, 2, 3, 4, and 5. That's the top of the graph. And then we're also going to go down 5, -1, -2, -3, -4, -5, and that is the bottom of the graph. There is no no horizontal shift, so the phase shift is 0. So the y-axis, x equals 0 here, is the start of the graph, and it is a distance of 8. The period has a length of 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8. That's going to be the right edge of the graph. Okay, so we now see this big rectangle. We know the midline is the x-axis. Okay, so we're ready to go ahead and draw our cosine graph. This time, remember, cosine looks a little different. So cosine starts at the maximum. It kind of goes down to the minimum, and then it comes back up to the maximum. Okay, so all of that little max to min to max, I'm going to put inside this big box. So the maximum is on the left edge of the graph, the left edge of the box, and it's at the top, so the top left corner. And it's also going to end in the top right corner. So these are the two starting and end points. In the middle, so halfway between 0 and 8, which is at 4, that's where it's going to hit the middle. The minimum, sorry. So the minimum is going to be at 4. And for cosine, it crosses the x-axis, or the midline, halfway in between at the quarters. So halfway between 0 and 4 would be 2. Halfway between 4 and 8 would be 6. Okay. Now, what did I forget? My graph is reflected. Okay, remember we have that negative amplitude. So instead of starting at the top and going down and coming back up, it's actually going to start at the bottom. So I need to split my minimum and maximum. So it's going to start at the bottom. It's going to go up to the top. And then it's going to end at the bottom. So notice that the midline, where the 2 points on the midline, don't change. When it reflects, it's only the top and the bottom. Okay. So we're going to start at the -5. We're going to go up through the axis, x-axis, hit the 5, go back down through the x-axis to the -5. Okay, so let me just list out my points real quick. So it starts at -5, 0. It's going to pass through the x-axis at 2, 0. Its maximum is going to be 4, 5. It's going to hit the x-axis again at 6, 0. And then it's going to end at 5, -5. And I wrote that first point wrong. That first point should be 0, -5. Right? 0 in the x direction, 5 units down. So it goes from 0, -5 to the top at 4, 5, and back down to the minimum at 5, -5. Okay, so that's what it looks like. It's just stretched. Horizontally, it's stretched. Vertically, it's stretched. There's no shifts, and it is reflected. Okay, let's try another one here. This time we have y equals the cosine of the quantity x minus pi over 6. And then after that, it's plus 3. So I'll do the same thing that we've been doing. We're going to figure out the amplitude, which there's nothing in front of cosine, so we just assume that's a 1. The k value, there's nothing in front of the x, so we just assume k is 1. And if k is 1, then the period is going to be 2 pi, right? Because it's 2 pi over 1, which is just 2 pi. My b value, so I have x minus pi over 6, so b is pi over 6 units, and that's to the right because it's a positive pi over 6. And then the c value is 3. It's a positive 3, so it's 3 units up. Okay, so let's put this in here. We're going to have 3 units up, so 1, 2, 3 is our midline. And then it's 1 unit tall, so it's going to be a really short, narrow graph. So 1 unit up and 1 unit down. So the top of the graph is at 4, the bottom is at 2. I am shifted pi over 6, and I have a period of 2 pi. So if I start at pi over 6 and I travel a distance of 2 pi, that means I'm doing pi over 6 plus 2 pi. Or I could convert the fractions there, pi over 6 plus 12 pi over 6. That means the right edge of the graph, where it ends, is going to be at 13 pi over 6. So we're going to have a lot of these in here. See if we can fit them in here. So here's 1 pi over 6. There's 3 pi over 6. We might not squeeze it all in here. 5, 6, 7. We're not going to get there. So we're going to have to move where I'm going to put things here. So let me not use the y-axis that's in there. Let me travel, we'll go way over here. So let's say this here is the y-axis. Okay, hopefully I went enough. So we're going to have, here is 1 pi over 6, 2, 3 pi over 6, 4, 5 pi over 6, 7 pi over 6, 9 pi over 6, 11 pi over 6, and then 13 pi over 6. So we are starting here at pi over 6, and we're going to end at 13 pi over 6. Okay, and so we have this really long but narrow rectangle. Right, so it starts over here at pi over 6. It ends at 13 pi over 6. That's a distance of 2 pi. And the top is at 4. The bottom is at 2. So I got to squeeze my graph in there. Okay. Now, the graph is not reflected, so it's its normal cosine graph. So that means it's going to start in the top left corner, and it's going to end in the top right corner of my box. And it's going to hit the minimum right in the middle. So where's that going to be? From 1 pi over 6 to 13 pi over 6. The middle is at 7 pi over 6, right? That's a distance of 6. So from 1 pi to 7 pi is a distance of 6. And then from 7 to 13 is another 6. So, yeah, so it's going to hit here. Let me go ahead and write these. 1, 2, 3, 4, just so we're not confusing ourselves more. It's going to hit the midline halfway between. So what's halfway between 1 pi over 6 and 7 pi over 6? Um, you can kind of just eyeball that and guess it. We could also compute that by doing the average. So if we take pi over 6 and we add 7 pi over 6, and we're going to compute the average of that. Okay, so that would be 8 pi over 6, which is, and all that's over 2. 8 pi over 6 would be 4, yeah, I take a 2 out of both of those, so it's going to be 4 pi over 3, and that's still divided by 2. And we divide everything by 2, we get a 2 pi over 3. So 2 pi over 3, that would also be 4 pi over 6. So here at 4 pi over 6 is the middle. So once we know where that at, we can kind of figure it out. There's the distance from here to here is how far? 1, 2, 3 pi over 6, and then we're going to travel another 3 pi over 6, and another 3 pi over 6, and then another 3 pi over 6. Okay. So, and we can also compute that if we know the period is 2 pi, and we divide it by 4. So 2 pi over 4 would be pi over 2. But if I want to write that in terms of sixes, that would be 3 pi over 6. So again, that's the width of each of these. Using that, the set one we did before, take 2 pi over 4, take the period over 4. So 3 pi over 6. So it's going to hit the midline here at, what did we say that was? 2 pi over 3. So this one here is 2 pi over 3. And what's going to be between 7 pi over 6 and 13 pi over 6? That's going to be 10 pi over 6. So over 5 pi over 3. So again, you could write that in sixes as well. But so there we go. All right. So our cosine graph is going to start at the top. It's going to go down to the bottom, and it's going to curve back up to the top. And again, if we wanted to list our points out, we're going to start at pi over 6, 4. And then our next point at the midline is going to be 2 pi over 3, 3. The minimum on the graph is going to be 7 pi over 6, 2. It's going to hit the midline again at 5 pi over 3 and 3. If you, instead of writing 5 pi over 3, you could say 10 pi over 6. Same thing with the 2 pi over 3, you could say it's 4 pi over 6. And then our last point was 13 pi over 6 and 4 for the y coordinate. All right, so those are the 5 points that we're looking at, the 2 maxes, the minimum, and then the 2 points at the midline. All right, let's try one more. This one has all the transformations, or at least all of them, the coefficients. So y equals 4 times the cosine of 2x plus pi, the quantity 2x plus pi, and then minus 2. One thing you should notice on this one is notice this only has one set of parentheses. So it's just parentheses around the 2x plus pi. There is a 2 in front of the x. If we look at these other examples here, if we look at the general formula, I should say, notice the k value has to be factored away from the x. So I'm going to have to do a little bit of algebra on this one first before we can actually work with it. So let me, we're not going to change the 4 out front. So we're still going to have 4 times cosine. I'm going to have to take this 2x plus pi expression and factor a 2 out of both of those. So I'm going to take the 2x and divide it by 2, which leaves me with an x. And then I need to take the pi as well. So I need to take both of these and factor out a 2. So it's going to be x plus pi over 2. And that's going to end my quantity, my double quantity, and then a minus 2 on the outside. Okay, so always make sure that anything that's in, there's nothing directly in front of the x except for sort of an understood one. Okay, but once we get that, we can go ahead and follow the same process. So A, our amplitude is 4, not reflected. K, in this case, is 2, which means our period is going to be 2 pi divided by K, so 2 pi over 2, which is just pi. Our B value is, so it's x plus pi over 2, which means our B value is a negative pi over 2. So it shifted to the left pi over 2. If you did not factor out the 2, then you're going to get the wrong value for your phase shift for B. And then C is a negative 2. All right. So again, same process. We're going to start with our midline, which is a negative 2. And so we're going to draw our midline in here. The amplitude says we're going to go 4 units above that. So 1, 2, 3, and 4. So we're going to start at negative 2 and go up to a positive 2. And then we're going to go from a negative 2 down to a negative 6. Okay. So my graph has to be between negative 6 and a positive 2. Okay, because the midline's at negative 2, and we're going to go up 4 and down 4. Our starting point is at x, or it will be at x equals a negative pi over 2. And we're going to travel a distance of pi. So if we start at a negative pi over 2, and we travel a distance of pi, we're going to add those together. So I'll do common denominator. So negative pi over 2 plus 2 pi over 2 is going to become just a positive pi over 2. So my graph is going to go from negative pi over 2 to a positive pi over 2. All right, and I need to divide that into equal pieces so that we can figure out where all of those points go. And if you remember to do that, we can take what the width of each of those little pieces is going to be, take our total period, which in this case is pi, and we're going to divide that by 4 because there's 4 pieces if you have 5 points. So that means we're starting at a negative pi over 2, and we have to travel a distance of pi over 4 to get to the next spot, to the next point. If I wrote all of these with the common denominator, then that means we're actually starting at a negative 2 pi over 4, and we're ending at a positive 2 pi over 4, right? Because 2 pi over 4 is the same thing as pi over 2. So hopefully that kind of helps see where we're going to be going. I'm going to space out my x-axis here. So this one on the left edge is going to be a negative, we can write it with a common denominator, negative 2 pi over 4, but that's really just negative pi over 2. And then the next one is going to be a negative pi over 4. 0 is in the middle, and then we're going to have a positive pi over 4, and then a positive 2 pi over 4. And remember, 2 pi over 4 is just pi over 2. So we're going from negative pi over 2 to positive pi over 2, and we have all the points in between. Okay. So my left edge is at a negative 2 pi over 4. My right edge is at a positive 2 pi over 4. I'm drawing the cosine graph. It's not reflected. So we're going to start in the top left corner and end in the top right corner. We're going to hit the bottom in the middle, and then we're going to hit the midline. Whoops, my midline is not. My midline is the negative 2, so my bottom is at the negative 6. We're going to hit the midline at the negative pi over 4 and the positive pi over 4. So my graph is going to look something kind of like that. Okay, so if I wanted to list out what my coordinates were, my first coordinate would be at negative pi over 2, 2. Okay, that's my starting point. The next one is at negative pi over 4. So negative pi over 4, comma, negative 2. And then we have 0, negative 6. We then have pi over 4, comma, negative 2. And then the last point, again, we know it's at pi over 2, and the top is at a positive 2. So these would be the 6 points where I hit the maximums, the minimums, and then the midline. Each one of those points is a distance of pi over 4 from the previous one between each other, and it should follow maximum down to minimum, back up to maximum as we go through them. Okay.